I'm going to explain another AQ A level exam question. So this is question 7. First of all, I read the question. Here we have a MCQs type question. We have to find the trajectory of a charge particle. Trajectory of a charge particle when this charge particles enters at right angle to uniform electric field and as well as a uniform magnetic field. Okay, so first I will discuss when a charge particle, any charge particle, when it enters into the right angle to the electric field and to the magnetic field. So for example, here is a figure A. This figure A shows that there is a uniform electric field, uniform electric field that is going from positive terminal towards the negative terminal. And for example, here is a charge particle that enters into this field perpendicularly. Mean here is velocity direction is towards the right side along the x-axis. So here the uniform electric field is towards the downside. So the direction of electric field intensity is downward, and the charge particle is moving towards the right side. So there is an angle of 90 degree, angle of 90 degree. So it means when charge particles enters into the field, electric field, that is the angle will be if the angle is 90 degrees. So what is going to happen? What is the trajectory? We have to find the trajectory. Trajectory means the path followed by this particle. Okay, path followed by this particle. Okay, definitely this charge will deflect this, this positive plate will deflect, will repel this, and negative will attract. And definitely the path of this charge particle, I explain this, I write this with the dotted line. Okay, the path is it just like that. Okay, this direction is actually the parabola. This is a parabola, just like a parabolic path. So the charge particle follow the parabolic path. Okay, now so option A is parabola. Okay, option uniform electric field, the charge particles move in the parabolic path. Okay, now I will explain how when the charge particles enters into the magnetic field. For example, there is a charge particle that enters into the magnetic field. So its speed is, for example, its speed is downward. Magnetic field B is into the page, mean hitting the screen along the negative z direction. So the charge particles enters into the field with speed v. So speed is v, and the magnetic field hitting this page. Okay, now the magnetic force will be inward if we apply the right hand. As we know that magnetic force is if F is equal to Q into V cross P. So it is the cross product of velocity vector and the magnetic field. So force is perpendicular to both. Okay, so the force will act inside. Okay, this charge particle will move inward. So when it moves, so when it is at this position, its speed is towards the, you can say that towards the right side, but the magnetic forces, its speed is toward the right side, but the magnetic force is again inward. So it will be deflected again, it will go follow this path. Okay, so the magnetic, now the speed is upward, but the magnetic force is again inward. So it will follow this curve path and it will be here. Okay, so when again its speed is towards the right side, but its magnetic force is toward the inside. Okay, so it means the magnetic force provide the centripetal force, means the this charge particle will follow the circular track. Okay, I did not make the exact circle, but it exactly follow the circular track. Okay, so first of all I have to explain why this force is toward the inside at every point. Okay, you can see that at every point, if I draw the right hand, if our right hand, so that I will explain here, I will explain. For example, if we draw the right hand, our right hand, this is our right hand, and the thumb shows the speed, the thumb shows the speed. Okay, and the palm shows the finger shows the direction of magnetic field, just like that. Okay, now the force is towards the palm. Okay, at every point, you draw the right hand, just like that your fingers is towards the magnetic field, directly pointing towards the magnetic field into the page. Your thumb is along the speed, so the force will be at this green arrow. This will be the direction of the magnetic force. So at every point we can see that the magnetic force is inward, so this will follow the circular track. So our option A is correct one. In the uniform electric field, the path will be parabolic path. Uniform magnetic field, the path will be the circular track. Circular track, as